All right, so now we're going to look at how we can apply ratio and proportion to word problems. So we're going to look at some simple word problems here, and excuse me. And we're going to look how to set these up. When we get a word problem, how do we set up these word problems? How do we rationalize this? How do we set it up so we can actually solve for a missing value? When you have word problems like this, you are actually able to use ratios and proportions to make predictions. If, for example, you've made somewhere between an 80 and a 90 on every assignment, chances are you're going to make between an 80 or a 90 on your next assignment. And we use ratios and proportions to predict, based on a given set of information, what do we think is probably going to happen. So let's look at how to set this up. So number 6 here on the example, and this is back on 8-1, Josefina sells helium balloons. She charges $9 for 12 balloons. At this rate, what would she charge for 50? Well, first of all, we need to set up some ratios. And then we need to get those ratios set up in a proportion that we can solve. And remember, a ratio is basically a comparison of two values by division, meaning fraction. And a proportion is a comparison or an equation comparing two equal ratios. So let's set up two equal ratios. Now, how in the heck would I do that? Well, the first thing I'm going to do is I'm going to say, all right, what are the items we have in this word problem? Well, we've got prices and we've got balloons, right? So let's underline our prices in red, or let's circle. I've got $9, and then I don't know what the other one is. What would she charge, right? I don't know, an X number of dollars. We don't know how much she would charge. I've got 12 balloons and I've got 50 balloons. So what we need to do is we need to set up two equal fractions that will enable us to solve for what she would charge for 50 balloons. When you set up these proportions, you have to have things lined up. They have to be lined up across or up and down, and I'll show you what I mean. So let's set this up. What would be our first ratio? Well, we know that she's going to charge $9 for every 12 balloons, okay? And this is our balloons. I'll put a balloon. I'll actually write out balloons. Let's just go all out here, shall we? So I'm going to $9 for every 12 balloons. So the question is, all right, if I want to use this to make a prediction, then the question is asking, how much would she charge for 50 balloons? Well, guys, I've got to line up my values. What's on top over here? Charging, money, okay, rate. So over here, rate has to be on top. And I don't know what that rate is, right? I'm trying to figure out what she's going to charge. What's on the bottom over here? Balloons. So what should be on the bottom over here? Balloons. So 50 balloons. What I've just done is I've set up a proportion. I know these two are equal. I'm trying to figure out what my value is going to be. So now I'm going to cross multiply. I know that $9 is going to give me 12 balloons. So how much money would give me 50? And don't worry about the units. I put those there so you can see what they look like. Let's go ahead and cross multiply. So I'm going to cross multiply. So I have 12 times x, right? Remember I said don't worry about the units? And I'm going to write this off over here so we have some more room. So I have 12 times x. Here I've got 9 times 50, which is 450. And again, I know these are equal. Remember on the previous video we talked about when you have a proportion, the cross products are equal. When the two ratios or fractions are equal, their cross products are equal. So I know 450 has to equal 12. So now I'm going to solve this just like I would an algebra equation. Remember, I want to divide both sides by what's in front of my x. And again, why do I do that? I don't want to know what 12x's is worth. I want to know what 1x is worth. And so 12 divided by 12 gives me just 1x. And then if I do 450 divided by 12, and I'm trying to do some mental math here, so that'd be 36, which would be 90, which would be That would be close. And I don't want to think right now. So I don't want to write the wrong answer on the video. So I'm thinking if I do 450 divided by 12, that's going to be about 75 halves. So maybe about 37.4, something in that area. Let me verify. 37.5. Now, what was it we were looking for to begin with? Charging, money, right? So what does that 37.5 represent? Money. So 37.5 is another way of writing 37.50 in money. So what we've done is we know, you can hear my children arguing in the background in the other room. If she charges $9 for 12 balloons, how much money is she going to charge for 50? $37.50. So let's go ahead and take a look at the next one, a photocopy machine. And on the photocopy machine, it says it copied 50 pages in 1.5 minutes. At this rate, how long will it take the machine to copy 90 pages? So again, let's take our colored pens or pencils and let's figure out what our items are. We've got pages and pages. And I've got minutes and X minutes over here, right? How long? That's what I'm looking for. Those are my minutes. So let's set up the proportion. 50 pages. I wish my kids would quit yelling. I'm so sorry. 50 pages took 1.5 minutes, right? And those of us that are teachers know that this is absolutely impossible because we've all worked with wonderful copy machines. That would be awesome if that's how much time it took. And let's look at what we should have on the other side. Well, pages is on top, minutes is on the bottom. So 90 pages should take how many minutes? We don't know. So you see how I've actually compared these, right? So at the top, remember, let's go back up to the top. $9 was 12 balloons. So how many dollars was 50 balloons? Now, could I have written that the other way? Could I have written 12 balloons on top and $9 on the bottom? Sure, as long as on this side I wrote 50 balloons on the top and X dollars on the bottom. Remember I told you line them up. Pages should be across from pages and minutes should be across from minutes. There's other ways you can do it where you can put pages over pages and minutes over minutes. I just don't want to confuse you, so I'm going to give you rates and keep it like this. We're just going to keep everything uniform. So now I've got two equal ratios. I'm going to cross product these. 90 times 1.5 is going to be 135. So I'm going to write 135. And 50 times x is going to be 50x. So again, to solve, I'm going to divide both sides by what's in front of my x. I don't want 50 x's. I just want to know what 1x is. So I'm going to do my division. I'm going to do 135, and I'm going to divide it by 50, and you get 2.7. And again, let's look at what I was solving for. What was I solving for? Minutes. So what that means is that if it takes 1.5 minutes to make 50 pages, 50 copies, it's going to take 2.7 minutes for 90 pages. So hopefully you're getting an idea of how to set up these word problems. Hey guys, so this one is a little bit different, and this one is where you're really going to have to organize your thoughts. The thing about proportions is that you can form them in multiple ways, and I'm going to show you. Let's go back. You see this one here where I did the balloons and everything like that? I could have set this up differently. I could have said $9 over X dollars, and I could have done dollars over dollars equals 12 balloons over 50 balloons. Do you see how I'm still lining these up down or straight across? I don't have anything diagonal. I can do dollars over dollars equals balloons over balloons, Or I could do dollars per balloon equals dollars per balloon, as long as both the dollars are across from each other or up and down from each other, and the same with balloons. You just don't want anything diagonal that goes together. The 9 doesn't go with the 50. The 12 doesn't go with the X. That's why they're diagonal for each other. You don't want the 9 and the 12 to be diagonal, and you don't want the 9 and the X to be diagonal. Same principle down here with the printer. I could have said 50 pages over 90 pages means 1.5 minutes over how many minutes? Again, do you see how I have pages over pages, minutes over minutes? I have an up and down, or just like on the previous one, straight across. I don't have anything diagonal from each other that goes together. So I could have solved it that way. When you get to a problem like this, you kind of have to be creative and think about how you want to solve this. So it says a recent school bond issue passed with 3 out of every 4 votes in favor of the bond. If 2,550 people voted against the bond, how many people voted in favor? So here, first of all, let's make a list. We're looking for people in favor and people against. Okay. Now, let's look at votes. 3 out of every 4 votes was in favor. Now, so that means we've got 3 votes in favor. But how many votes does that mean against? This is a thinker. If 3 out of every 4 total votes was in favor, that means 3 were in favor, 1 was against. Does that make sense? Because there's 4 total votes, 3 were in favor, that means 1 was against. Okay? So now let's look at people. How many people voted in favor? We don't know how many people voted in favor. What do we know? 2,550 people voted against. So there's 2 ways you can set this up. I'm going to start showing you both ways for each one. The first one is to set it up just like you see it. Votes over votes equals people over people. I can just set it up like this. Because don't I have in favor with in favor and against with against? They match, right? So let's cross multiply. 1 times X is X. And 2,550 times 3 is 7,150, I believe. Let's verify that with the calculator because sometimes COVID math is not all that great. So 3 times 2,550, yes, sorry, 7,650. I knew I was making a mistake there. So I've got 7,650. Now, that's how many people, what? What am I solving for? Remember, these were people against. So these were people 4. So there's your answer. You're just solving for X. 7,650 people. Make sure you put your units. Now, I could have set this up a little bit differently. Remember, I told you there's multiple ways now that you can set these up. They can be up and down from each other, the matchers, or they can be across. I could have said 3 votes went with how many people? Because remember, we're talking about on this side, 3 votes for was how many people? If 1 vote against was 2,550 people. And I could have cross-multiplied these again and get the same answer. Again, look, do you see how I have votes and votes are lined up and down? Votes and votes are lined up across. No diagonaling. And they match up. 3 votes on top means the people 4 on top. 3 votes on top here, people 4 go with it. 1 vote on top, people against go with it. So you can solve it both ways. When you solve it, X times 1 will be X, and 3 times 2,550 will be the 7,650 people. Same answer. Okay? So that's how you solve word problems with proportions. That'll give you a little bit of an example on how you solve different kinds.